This is Module 3. We're going through Example 3, and it reads as follows. Suppose we have the following hypotheses. The null hypothesis is that pi equals 0.16. In context, that reads 16% of people experience negative symptoms when taking this drug. The alternative hypothesis reads pi is not equal to 0.16. In context, the proportion of people who experience negative symptoms when taking this drug is not 16%. Notice, to say that it's not 16% could mean that it's more than 16%, or it could mean that it's less than 16%. This is called a two-sided test. If we have enough evidence that it's bigger, or we have enough evidence that it's less, that we could say that we have evidence that it's not. All right, we're also given that we have a p-value of 0.062. So I've already drawn here an example of the null distribution, the distribution of sample statistics. Know that the distribution would be centered at the value hypothesized in the null hypothesis. So it would be centered at 0.16. This is the distribution of expected sample statistics. If you went out in the world and it were true that 16% of people experience negative symptoms and you collected a sample, then you would expect to get a sample statistic a little above 16% or a little below 16%. So if we got a p-value of 0.062, again, remember what a p-value means. It means if the null hypothesis is true, then the probability of getting a sample statistic like ours or more extreme is 0.062, 6.2%. So, or more extreme, what does that mean in this situation? If the alternative hypothesis had been less than, then we would count or more extreme as the dots that are less than our sample statistic. If the alternative hypothesis had been greater than, then we would count the dots that are like our sample statistic or greater. But in the case where it is not equal to, the or more extreme will be counted on both sides. We're going to count dots on both sides, in both tails of the distribution. So we have a sample statistic somewhere on here, and it turns out that 6.2% of the total dots in our distribution are more extreme than our sample statistic. So since we're counting on both sides, that would mean that we have a sample statistic that's either down here or up here. I didn't tell you in the problem, but 3.1% of the sample statistics in the null distribution are down here below this line, and another 3.1% of the sample statistics in the null distribution are above this line. So perhaps our observed statistic p-hat was down here. It is a certain distance away from the middle of the null distribution. On this other side, if we go up that same distance, we would then mark off that line there, and we would count the dots above there, and we would count the dots below here, and when you add all of them up together, they make up 6.2% of the total sample statistics in the null distribution. So the sample statistics that are like ours or more extreme or further away are 6.2% of the total sample statistics. Okay, again, part A is asking us to write out that contextual sentence that interprets the meaning of the p-value in context. All right, and so I took our usual sentence about p-value definition and I put it in context. It would read, if we assume that 16% of people experience negative symptoms when taking this drug, notice that's us assuming the null hypothesis is true, then the probability of getting a sample statistic like ours or more extreme is 6.2%. That's the p-value. And again, just keeping in mind, what do we mean by or more extreme now? When it's a two-sided test, or more extreme means like our sample statistic or further away in the tail on either side. Part B asks us to give that contextual conclusion overall. So we want to say, do we think the null hypothesis is plausible, or do we have strong evidence in support of the alternative? We have a p-value of 0.062. That is more than 0.05. So I would conclude that the null hypothesis is plausible, because I generally say if it's more than 0.05, that we would call the null hypothesis plausible. Putting that in context, then, we would say that it's plausible that 16% of people experience negative symptoms when taking this drug.